We'll move on to the next topic. The next topic is the properties of the binomial expansion. The property of binomial expansion, right? So the expansion what we are talking now is generally denoted as x plus a to the power n. So the first and foremost property of this expansion is going to have totally n plus 1 terms. This expansion will always have the n plus 1 number of terms. Right. So we always have, we also can use the property like this. So we know that the NC, if at all I see a term NCR, I can actually replace that as NC n minus R. So according to that, I can definitely apply the NC naught is equal to NCN that is equal to 1. So whenever I expand, I try to use this property. Okay, then the NC1 should be NCN minus 1. What is NC1? NC1 and NCN minus 1 will be always same, and that is equal to n, right? Similarly, I can also apply NC2 is equal to NCN minus 2. So NC2 should be n into n minus 1 divided by 2 factorial. That's anyway, I can write it as 2, but according to the rule, it is 2 factorial. So this can be applied to every term that is present on that expansion, right? Instead of finding NC n minus 2, you can simply apply NC2, right? Then in any of the term, the suffix of C is equal to the index of A, right? And the index of X, right, is equal to n minus the suffix of E. Anyway, we know that, so I don't want to write that. So let's move on further. Each term, the sum of the indices of X and A is always n. Yesterday we have seen that, so we already always have used this. The next property that we can use is this. So we know that if I try to write NCX and NCY, they are same. X is equal to Y and n is equal to x plus y. Let's write this. This is used many times. So if somewhere we see that NCX equal to NCY, this implies either of the following is true. Either x is equal to y or n is equal to x plus y, right? Either of these cases must be true. Right. NCR is NCN minus R. I can also use this again and again in the problem. So NCR is equal to NCN minus R. So both are going to have the same notation. This is n factorial by R factorial into n minus R factorial. Directly we can use it. Also, we use another very important property from the permutations and combinations. So that property is this: NCR plus NCR minus 1. We already have used this. So NCR plus NCR minus 1 is always n plus 1 CR. We already have used this. And the next important property we are going to use will be this one. The NCR divided by NCR minus 1. This always will be equal to n minus R plus 1 divided by R. Also, one more property we use occasionally is this: NCR can be replaced as n by R times n minus r c, sorry, n minus 1. This is n minus 1 c r minus 1. All right. Now, let us try to draw some of the very standard. So let's start with the some of the very fundamental expansion. So if you want to write, say, x plus a to the power 0, anything raised to the power 0 is 1. Next, let's write x plus a to the power 1 is nothing but this is x plus a. Right, let's write another term. Now, x plus a, the whole square. Okay, x plus a, the whole square. Anyway, we know how the expansion. I can write x squared plus 2 times x into a plus a squared. You see that x power keeps on reducing and a's power keeps on increasing as I move from left to right. The same rule which we have applied, actually, even without using this, I can write the expansion using the binomial expansion. It is n is equal to 2. So, right, I can see that this particular function is 2c0 into x to the power 2, a to the power 2 minus 2, so 0, plus 2c1 x to the power 1 a to the power 1 plus this is 2c2 into x to the power 0 a to the power 2. So 2c0 is 1, so this is just x squared, plus 2c1 is 2 into x into a, plus 2c2 is once again 1 into x to the 0 is 1 into a squared. So you see that you get the same thing. That's what we are writing here. Okay, so expanding using the binomial is the easiest way to get the answer whenever we don't know the answer. All right, okay, let's move further. Now, let's use this in few more cases. This is x plus a whole cube, right? So x plus a the whole cube can be expanded in the same way. So first you will have 3c0, which is 1, into x to the power 3, right? Plus 3c1, which is 3, into x power reduces x square, a power increases, a power 1, previously a power 0, now a power 1, plus next 3c, this is 3c0, 3c1, 3c2, 3c2 is same as 3c, 3 minus 2, which is 3c1, 3c1 is 3, into x power further reduces, a power increases, x a square, plus last term is 3c3, which is 3c0, 3c0 is 1, x power reduces to 0, a power raised to 3. So this is a cube. All right. So like this, you can expand any term you want, right? Let me write few more terms. So I want you to calculate x plus a power 4, just as a practice. Okay, so this is equal to, fine, we have x to the power 4 4x cube a, correct, plus 6 x square a square, right, plus 4 x a cube plus a to the power 4. That's right. So now one thing is very important, very easy to understand this whole concept. Even if I don't know how to write, right, any expansion, I can understand one thing. Very important. So from the middle term, everything is symmetric. What you have here, the same coefficient on other side. There is one here, there is one here. This is the central term, midterm. Okay, let's move further to just verify this concept. If you have just 3 terms, I can identify the midterm easily. But now you see in the next one, I don't have 3 terms, I have 4 terms. So this is the midpoint. Whatever coefficients you have, they are same. So 3 here, 3 here, 3 into 3, and 1 and 1. Okay, it repeats. See the next example. In x plus a to the whole raised to the power 4, this is the midterm. I have 4 here, 4 here. 1 into a, 1 into x to the power 4. So the coefficients are actually, right, going to remain same about the midpoint. That's another way in which I can actually calculate this much faster. Let's go for another example in which you will be able to do this much faster because you observed one property now. So I want you to do the calculation for x plus 5 raised to the power 5, x plus a raised to the power 5, right? And also I want you to calculate another number, that is x plus a to the raised to the 7. Okay, this is equal to, yes, into a, right? Yes, x cube a square 10x square a cube, right? Okay. X into e to the 4 plus a to the 5. Correct. Okay. This is equal to x to the right. Okay. Right. 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 X into 6 plus a to the 7. All right. So in all such cases, it's very easy to calculate. Only you calculate half of the terms, right? This much you calculate, then repeat 10, 10. 3 plus 2 becomes 2 plus 3. Then 5 will be repeated to this side, right? X to the 4a becomes x into a to the 4, right? Then this comes here with the same coefficient. Okay, so every x and a you interchange to get this. So half of the terms you can calculate, remaining you can write easily. All right, this is actually implicated in another format which is called as a Pascal's triangle. So let's try to understand the Pascal's triangle now. So what I write is a Pascal's triangle. So the first term, x to the x plus a to the 0, it has only one term, that is 1. Then the next one will have two terms, that is 1 and 1. Okay, so 1 for x, 1 plus 1 for a, that's denoted here. So the next term you see will be written directly. So the first one which is here, I can write it as it is, directly 1 and will be written. Now, just to calculate the midterm, the coefficient of the second term of your expansion, right? We can calculate that easy. So I just write 1. Then this 1 plus 1, 1 plus 1 is 2, right? I'll write the 2 at the middle and copy 1 once again. So this is 1, 2, 1. Same thing can be applied further, right? This 1 is copied to this side, right? Then 1 plus 2 is equal to 3. 3 plus 2 is 2 plus 1 is equal to 3. And this 1 is copied once again. So you see this is 1, 3, 3, 1. That's what is this. So the coefficients of binomial expansion can be calculated for any term using this. Let's do one, right? So the 1 comes here. The 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and the 1 comes once again. Okay, so this can be expanded any further. Let's do one more for the fifth term. This is 1, 5, 10, 10, 5, 1. So you see that's the coefficients which you have here, right? So very straightforward way to do this. This is called as a Pascal's triangle in mathematics. All right. Okay. Then just practice. You can do this for, you can verify whether it's right for the length 7 which we have done. So, right. So write a 1 coefficient for 6. Then you can expand that for 7 at a later stage. Okay. So let's do that now. So this becomes for expansion x plus e to the power 6. The coefficients will be 1, 6, 15. Right. This is 20, 15, 5 plus 1, 6, and another 1. Okay, that's what. So obviously the 7 becomes, this is 1, 6 plus 1, 7, then 21, then 35, then it will repeat 35, 21, and 7 and 1. So that's the Pascal's triangle we are looking for. Same things have been written here when we expand it. All right, let's move further. Right, let's look at the general terms. For any expansion, what is the equation for a general term? Right. Now, any term number r plus 1. R plus 1th term in the expansion is given by NCR x to the power n minus r into a to the r. Right? This is the r plus 1th term of the expansion. Right. So this is one fundamental equation we need whenever somebody asks you a question like this. So this is a question based on this concept, right? The find 7th and 11th term of 4x minus 1 divided by 2 root x raised to the power 30. This power is 1, 3, 13. When that is expanded, what is the 7th term and the 7th, 13th, 11th term? We need to find. So the question is T11. I have to write it as first we'll find 7. So when I want to find T7, I just have to write it in the T6 plus 1 because R plus 1th term is what we want, right? So R is 6 now. So I have to write, so N is equal to 13. So this is 13C6. X is what? X is the first term, that is 4x raised to the power n minus r. N is equal to 13. 13 minus 6, okay, is the power. And the second term, that is a is equal to minus of 1 by 2 root x raised to the power r. So that is 6. So I need to simplify. So this is equal to, let's calculate a 13C6 later, right? Let's first try to find. So 13 minus 6 is 7. So this is 4 raised to the power 7 into x raised to the power 7, because 4 to the power 13 minus 6 and x to the power 6 into, we have negative number. So you see minus 1 raised to the power 6 is a positive number. So negative term goes away. I don't have to write the minus sign. So just write a first, just write positive term. So this is 2 raised to the power 6 into, this is x to the power half, x to the power half raised to the power 6. So this is equal to x cube. Okay, I can write it as x cube. Now let's simplify. So calculate what is the value of 13C6 into 4 to the power 7 divided by 2 to the power 6. That's the constant number. Please calculate that. Okay, this is equal to 4, 2, okay, 4, 3, 4, 3, 9, 2, 96. That's a simplification of 13c6 into 4 to the 7 into 1 divided by 2 to the 6, right? Okay. So next, powers of x to the power 7 in the numerator, x to the 3 in the denominator. So 7 minus 3 is equal to 4, right? So the expansion gives you, simplification gives you x to the power 4. Okay. So that is the seventh term of this expansion, right? Very similar to this now. We have to calculate the next term, that is T11. So T11 can be written as T10 plus 1. So my expansion is 13C10 into 4x raised to the power 13 minus 10 into, this is minus 1 divided by 2 root x raised to the power 10. Okay, in a very similar fashion like previous one. Okay, this comes to be 17.875 x to the minus 2. Another problem. Find third, sixth, and the ninth term of, this is a term, this is 3x minus 4 by x squared to the power 30. So in this, find the third, sixth, and the ninth terms. Okay, after we solve, we get T3 equals to, okay, okay, all right. One six four x power minus 2. Okay, and 2.04. All right. Okay, this is one set of question. Next type of question that commonly comes over here is like this. Find the coefficient of x to the power 8 in the expansion of x square minus 1 by x to the power 10. So one important point here is that we don't know which term we are looking at. X to the power 8 can come anywhere. It's not eighth term. So you see the example. So x to the power 7 came in the third term, right? Previous problem, right? Like that. We can get the x to the power at any term. I don't know what term it is. So now the question is, what is the coefficient of x to the power 8? Which means some number is the answer, right? Like 22107946 or 8.64 or 2.0 or something like that. We have to give a answer. This is the coefficient of x to the power 8. So in order to find this, my objective is that I need to find out what is the value of r first. So in order to find the value of r, right, let's generally write what is tr plus 1 for this given problem. Okay, so tr plus 1 is n is equal to 10. So ncr into the first term, that is x square raised to the power 10 minus r into minus 1 by x raised to the power r. So let's try to simplify this further. So this is 10 cr x raised to the power x square is there. So 20 minus 2r x square raised to the power 10 minus r. So into this is, there is a minus 1 raised to the power r into this is x to the power minus r. So let's try to simplify. There is a minus 1 raised to the power r into 10 cr. This is the coefficient into x to the power. So 20 minus 2r minus r. So minus 3r. Now you see the idea is I have to have an 8 here. X to the power 8 comes with some r. That r you put here to get the coefficient. Very simple. Straightforward. Okay, this is tr plus 1, right? So in order to get a x to the power 8, right? X to the power 8 should be equated to x to the power 20 minus 3r, right? This implies 20 minus 3r is equal to 8. So 3r is equal to 20 minus 8, which is equal to 12. So r is equal to 4. Put r equal to 4 here, right? So this implies, right, coefficient of x to the power 8 is equal to, put r equal to 4 in the coefficient part. This is minus 1 to the power 4 into 10 c4. That's all, because I don't have to write this number because it's x to the 8. All right, so when we simplify this, we are going to get minus 1 to the power 4 is plus 4 into 10c4. 10c4 will be 10 into, okay, 10c4, 10 into 9 into 8 into 7 divided by 4 factorial. That is 4 into 3 into 2 into 1. 210 is the answer. Next question. Find the coefficient of x to the 6 and x to the 10 in the expansion of x cubed minus 3 by 4x square raised to the power 50. So first we will write the tr plus 1, right? Okay. So tr plus 1 is equal to 15cr multiplied by the first term, that is x cube raised to the power 15 minus r, right, into the second term, that is minus 3 by 4 x square raised to the power r. Okay, we need to simplify this. So this is equal to 15cr x to the power 3 into 15, 45 minus 3r into, there is a minus 1 raised to the power r into a 3 to the power r. Okay, and 4 to the power minus r into x to the power minus 2r, right? 4, 1 by 4 to the r is 4 to the minus r. X to the x square in the denominator, so my x to the power minus 2. Okay, so this means 15. Let's write the constant first. 15 CR is first term, minus 1 to the power R. Then this is 3 to the R, and actually you can even write this is 3 by 4 to the power R, right? 3 to the R and 4 to the power minus R. Even the minus 1 can be taken inside. Let's write it in a much simpler way. So this is minus of 3 by 4 to the power R. We can write as this. We don't have to change this. So this is into minus 3 by 4 to the power R. Let's write the remaining term. So this is x to the power 45 minus there is a 3R and 2R. So minus 5R. Okay, x to the 45 minus 5R. So try to simplify this. So this is, now this is the term. I just have to find out uh, at what point this expansion becomes equal to 6, right? So 6 means I have to write 45 minus 5R is equal to 6, right? So when I have 5R is equal to 45 minus 6, that is 39. Okay, now this is the important point. If you don't get a whole number as an answer, then there is no x to the 6 in the expansion. Okay, so 39 by 5, 40 by 5 is fine, but 39 by 5 is not a whole number. So R is not a whole number. R is equal to 39 by 5. It is not a whole number. This means, right, there is no rth term which represents this, right? There is no rth term which satisfies this condition. Okay, so there is no x to the power 6 coming in the expansion of this whole term. That's what is the meaning. So you can actually write, this is the answer, right? No term has x to the 6 in the expansion is the answer. Okay, just to show that there is a condition like this problem is given.